Now we're going to be working on a synthesis problem. We're going to plan how to make a molecule using Grignard reactions. So the way to do that, let's say we're going to think backwards. Let's draw the molecule that we want to synthesize. As we see here, that's a secondary alcohol. And there is a couple ways that we can do that using Grignard. For that analysis, as I said before, thinking backwards, we're saying this is retrosynthetic analysis. And or also in books, in other places, we will see that as disconnection approach. And what we're doing here is thinking in ways of breaking that, disconnecting, and forming a couple of fragments. So say that I want to disconnect that. Remember that Grignard reactions, typically you can do that with ketones or aldehydes. And if you do that, disconnecting right here, we can say that this may come from the reaction. So disconnecting here, make this your aldehyde portion. And again, why do we think this is an aldehyde? Because we know that when we react aldehydes with Grignard, we produce secondary alcohols. Secondary alcohols. If it was tertiary, we want to start with a ketone, for example. So now disconnecting it that way, now this comes from an aldehyde, and then this fragment with 3 carbons needs to come from a Grignard. So my reagent now, say for example that I have metal, this will be propyl, 1, 2, 3 carbons, right? So propyl, magnesium bromide, in even disconnecting more, when you plan the synthesis, this can be made from the reaction of propyl bromide and magnesium using dry ether. So this is what you will do. And so that's one way of making that Grignard. So again, we had disconnected, and you can test that if this is true. How we will do that? Remember when we study mechanism, it's because that helps us predict products. And now the polarity of this bond, we said is almost ionic in character. So we're gonna draw this. And for your mechanism, you will have, again, as we've seen before, a nucleophilic attack. And you see that that reaction there produced, let's draw that, and here you have added 1, 2, and 3. This alkoxide, and then after protonation, well, here you don't have you have the H. So yeah, I'm right. So you have ethyl propyl in that H. So this, after protonation, after you add water, you have formed the alcohol that you wanted. So that's one way of synthesizing that compound. But I can do another way. And I'm going to now disconnect this side. If I disconnect that side instead of the other, now I can make another aldehyde. So right here where I disconnected, this fragment will come from a Grignard, and the other fragment that has the oxygen will come from an aldehyde. Again, the same criteria, the secondary alcohol, you will need an aldehyde to make that reaction. So disconnecting here, you will have 1, 2, 3, and here you will have the aldehyde. Now you're starting here, you have started with this aldehyde, this has 1 more carbon, right? So this is butanol, and that was propanol. Okay. And so the second step of that, I'm disconnecting and saying that this fragment should be my Grignard, and that Grignard needs to have 2 carbons. So now this comes from ethyl magnesium bromide, for example, and you can synthesize that from ethyl bromide, and you do magnesium. So now we can always check if we did it correctly by doing the reaction. So remember, polarity of that bond is this way, and you will do the nucleophilic attack over here, over the electrophilic carbon, your final product of that reaction is then 1, 2, that here, notice, is that oxygen. You make that alkoxide, you had attack with 2 carbons. The hydrogen is there, I didn't draw it. So you have the same alcohol, again, after protonation, of course, you will get your target molecule, that alcohol. So we add water in the final step. So notice then again that you can do 2 possible disconnections, and one of them is where you have the oxygen here is a fragment that will be coming from an aldehyde, because again, forming a secondary alcohol, you need an aldehyde here with a Grignard. The fragment with the oxygen would be the one, in this case, this is a disconnection, say in yellow, coming from that aldehyde, and the other fragment is the Grignard. And here I broke in a different way. The fragment that has the oxygen is these aldehyde with 3 carbons. The other fragment is your Grignard that actually will have 1, 2, 3 carbons. So we have 2 ways of making that molecule.